So here's what we're going to be doing today. So last time we started talking about the three major motions of the Earth. Three major motions of the Earth. Motions of the Earth. And we listed them: rotation, orbit, and precession. And last time we talked about precession and rotation. There's a little bit more I want to say about rotation today, and then we'll move on to the orbit. Okay, so just a reminder, remember, rotation is something spinning around its own axis, and the orbit is moving around another object. Okay, now, rotation. So last time we defined what days were, but I want to talk a little bit more about how the sun and the stars move across the sky. So that daily motion of the sun across the sky, and then at nighttime the stars across the sky, that's from the rotation of our planet, right? But a lot of times people have the wrong idea about how things move across the sky. Like imagine the sun rising. Imagine the sun rising. Just imagine it real quick. Now you're probably imagining it rising like this. And then going up the sky, and then eventually it'll go over you and come back down the same way. Okay? Now, I'm not sure exactly where all of you are living, but that won't happen for us here in Florida, okay? That won't happen for us here in Florida. That's not how the sun rises and moves across the sky. It doesn't rise straight up and then set straight back down. And there's a reason for that. It's a little bit tricky to figure out. An easier question to ask than why doesn't that happen for us here in North Florida is what is the only part of the planet where the sun will rise straight up and actually hit your zenith? We actually talked about that last time. Where's the only part of the planet where the sun will hit your zenith at least one day during the year? Roughly. Yes, the tropics, right? So if you live in the tropics, the sun's going to go up and hit your zenith at least one day, right? But the only place where the sun will rise perfectly straight up and then go perfectly straight back down is actually perfectly at the equator, okay? So here we go. Got a picture right here. Imagine that this, let me zoom in a little bit. Here's two people at two different places on the Earth. This person is standing right at the equator, and this person is standing maybe North Florida or some other place that's north of the equator, okay? All right, we already got my first little freeze. We're working. All right. Now, as the Earth turns, it looks like the sky spins around us, right? So, because the Earth is turning around its axis, and this person is standing perfectly on its side, then that means that the sky is spinning around roughly that line. So that means that everything in the sky is just going to spin like this. All of the stars and the sun are just going to rotate perfectly vertically from this person's point of view. Everything rises straight up, set straight down, and then they can't see it when it's down here because it's behind the Earth from their point of view. So if you're standing right at the equator, objects will rise straight up and then come straight back down. So let's see what's different about the person standing up here in North Florida. Check this out, okay? The sky is still going to spin around its poles because the Earth is spinning around the poles. But because this person's not perfectly on the equator, everything's diagonal in this picture, right? The sky is spinning like this, right? So that means that everything in the sky, including all the stars and the sun, is going to spin like this in this picture. And that means that this guy is going to see things come out. Check this out. This is a little bit tricky to picture. He, again, still can't see stuff down here. This is what he actually sees. That's his part of the sky. And so if you see here, see how the paths of everything move on these diagonal rise and set paths? As they rise, they'll come up like this, and they'll set like this. So basically what I'm getting at here is that for us in Florida, everything is going to rise at an angle and then set at an angle. Here's a picture from your book. This will help you see what I'm trying to say. Right here, everything is rising at an angle and setting at an angle. And that's actually why the sun won't hit your zenith. Because of this angled path, it kind of swoops around your zenith on the way across the sky. Okay, check this out. Here's my next question. Check this out. If I go back to this picture, I just said if you're at the equator, everything rises straight up and sets straight down. And if you're a little bit north of the equator, everything's going to be rising at an angle. What would happen to the angle if we went further north? Okay? If we went further north, what would happen to this path? Would it stay exactly the same as Florida? No. What would happen to it? Let's see if we can figure that out. If it's perfectly straight up and down at the equator, and here in Florida it's a little bit tilted, if we were to travel farther north, what would happen to this path? Would it become more or less tilted if we moved farther away from the equator? That's what I'm asking. Hopefully I'm making sense here. More. That's right. So the closer you are to the equator, the more straight up and down the stars and the sun rise and set. As you move away from the equator, that path slowly tilts. Okay, the path of the stars and the sun in the sky tilts. All right? And if we keep doing that, if you keep going north away from the equator, eventually you're going to hit the North Pole. Okay? Eventually you're going to hit the North Pole. All right? And if you're standing there, then the sky is still rotating around that line. It's still rotating around the North and South Pole. And that means that everything's going to spin like this. Okay? And that means that the stars and the sun move left to right. And if those stars are moving left to right like this, what will those stars never do? What will those stars never do if they're spinning like this in the sky? What will they never do? I might not be making a lot of sense. This might be too vague of a question. For us, here in Florida, the stars are rising and setting because they go under the planet, right? Whereas over here, because the skies are just spinning in the sky, they're never going to set at all, okay? So that means if you're living at the North Pole and everything moves like this, the stars never set that are in the sky. You see the same stars all day long and all night long because they're never going down, all right? And the reason I want to point that out is that imagine it's summer, okay? Imagine it's summer so that the sun is farther north than usual, so that the sun is out. If the sun is out and you're living at the North Pole, then that means that the sun is going to spin around like this in the sky. If the sun is out and you're living at the North Pole, this is how the sun will move. So what does that mean the sun won't do at least one day during the year? for this person living up here? What will that sun not do? Nah. Somebody guess. Well, it's definitely never going to hit your zenith, right? Because it'll never get up there. But it's stuck at one height in the sky. It will never set either, right? So it's never going to hit your zenith, and it's never going to set. So essentially, if you live close enough to the North or South Pole, there's going to be at least one day during the year where the sun does not set, okay? I actually have a couple of pictures of that. Look right here. Here we go. So right here, this is 24 pictures of the sun. This is somebody living close enough to the North Pole that the sun doesn't set. And what they did was they took a different picture of the sun every hour, okay? And this is a little bit confusing because they had to spin around in place to get that picture. So it's like they took a panorama shot all the way around them. And you can see here that the sun is sort of acting like it's gonna set, and then it's like, psych, never mind, right? So the sun would just continue to spiral around this person for 24 hours every day. So there's parts of our planet around the poles where this is going to happen at least one day during the year. And the closer you get to the pole, the more days this happens, okay? And there's actually a special name for that part of the planet, okay? What is that part of the planet called? Does anybody know what we call the part of the planet around the North Pole? Actually, I'll go ahead and give you that one. This region around the North Pole, where the sun doesn't set at least one day, is called the Arctic. This was our tropics. And does anybody know what we call the region around the South Pole? We call the region around the North Pole the Arctic. Does anybody know what we call the region around the South Pole? The Antarctic. The Antarctic. Yes, the Antarctic. We call the continent that's in there Antarctica. But yeah, basically what defines the Arctic and the Antarctic, that C should not be there. Arctic and the Antarctic, that's my bad. Those are the parts of the planet where the sun does not set at least one day during the year, okay? But if there's at least one day during the year that the sun doesn't set in those regions, then that means there's also going to be one day where the sun doesn't do what? What's the other thing that the sun won't do at least one day during the year in those regions? So it won't set at least one day during the year, and it also won't something one day during the year. Yeah, it's okay. Rise. There you go. There you go. You got it. You got it. Rise. Because of the way that the planet is tilted, check this out. Remember, in this picture, the sun is way over here. So when your pole is tilted away from the sun, and there's darkness over here, if you were to spin around this pole, you would stay in the darkness that entire day, and so the sun would not rise. On the other hand, if you were down here, tilted towards the sun, that's those days that the sun doesn't set, okay? So the Arctic and the Antarctic are just the parts of the planet where that happens.